Hi class, this is Professor Latham. I'll be doing a movie on hypothesis tests on the difference between population mean z-test. Past records suggest that the mean annual income mu1 of teachers in the state of Illinois is less than or equal to the mean annual income mu2 of teachers in Massachusetts. So I'm going to go ahead and capture that on my piece of paper so you can write it down too. I'm going to write down mu1 less than or equal to mu2. And then it says in a current study they had a random sample of 20 teachers from Illinois and then 20 from Massachusetts, and they reported their mean annual income. It says here that the population standard deviation for the mean annual income of teachers in Illinois and Massachusetts are 6,200 and 6,300 respectively. Notice here that when they give us the population standard deviation for the two populations, also that the sample sizes are small, less than 30, both were 20. Even though the sample size is small, because we're given the population standard deviation, we're going to use the z-test. It's also known that both populations are approximately normal, and then we're going to test this at, I believe, the 0.05 level of significance. Perform the one-tailed test to see if there's sufficient evidence to reject the claim that the mean annual income in the state of Illinois is less than or equal to the mean annual income of teachers in Massachusetts. So they've really given us one mathematical statement, mu1 less than or equal to mu2. Since they did not give us another mathematical statement, we're going to take what's the opposite of being less than or equal to. So less than or equal to, the opposite would be mu1 greater than mu2. And in order to determine the null hypothesis, that's going to be the hypothesis that has the equal sign. So let's go ahead and write that part in. All right. So I'm going to substitute in here mu1 less than or equal to mu2. And then I need to tab out so that it won't stay in the subscript position, and then less than or equal to mu2. This was the mathematical statement that was given. That doesn't mean that it's automatically going to be the null hypothesis because it was given. What makes it the null hypothesis is because it has the equal sign, and null means nothing's changed or status quo. And much like our judicial system, before the crime a person's innocent, and after the crime we say assume they're innocent until proven guilty. Assume status quo until proven guilty. Assume nothing's changed. So therefore nothing changing means everything's the same or it's equal. So the null hypothesis will always be the mathematical statement that has the equal symbol. Either this one here, strict equality, less than or equal to, greater than or equal to. And the alternative would be, what's the opposite of that? It's either one or the other. So it's going to be mu1 greater than mu2. Again, it's the z-test because we know the population standard deviation and also to the populations normally distributed. And then now they ask us to compute the test statistic. And so I'm going to go to list of formulas and ALEKS in order to compute the test statistic. And then when I go to list of formulas, there is a way that we compute the test statistic. This first formula is for finding a confidence interval. The second formula is for finding the test statistic. So it's always the estimate minus the parameter over the spread. So let's go ahead so you can see which is which. The parameter is always going to be in the first column. The estimate, here it is here, the estimate is here, the statistic, and then the spread is the standard error or the standard deviation. So our formula is always going to be this guy minus this divided by that. Is that just way too cool? So let's say that again. It's going to be estimate minus the parameter. In this particular case, what I'm showing you, it's mu. The estimating statistic is x bar. That's the sample. We're getting the sample, and we're going to make a judgment about the population parameter based on the sample. So it's going to be x bar minus mu divided by the spread. And that would be the case if we're estimating or finding a hypothesis test about the mean, and we knew the population standard deviation here is sigma. But in our case, it's the difference between two populations, so we need to find that one. So here we go, estimating mu1 minus mu2, and the standard deviation is known. Here that's the variance. So here they tell us the variance, sigma 1 squared and sigma 2 squared. So whenever they're known, this is the formula we use for spread. So I'll click on that, and then I'm going to plug in those two population standard deviations that they gave us in the problem. So see how it's filled into the ALEKS calculator? That's the spread. So let's go ahead and plug in, and they tell us that the two population standard deviations are, so it's 6,200, so I'll put in 6,200 here, and then 6,300, and the first sample was 20 and the second was 20. Remember, there were 20 from each state. And I hit the equal sign, and that'll give me the spread or the standard error. So I'm going to store that. If I clear it and hit recall, it brings it back up, so I'm just going to store that value. Okay. Now we remember from the list of formulas, it was the x1 bar, x1 bar, the mean for the first sample, minus the mean of the second sample, divided by, minus the parameter, divided by the spread. So let's go ahead and get the mean for the two samples. So I'm going to recall up that one. It turns out with the new ALEKS calculator, it only lets you store one thing. The other one, it would let you store several. So I'm going to write this down here. It says to carry my intermediate computation to at least 3 decimal places. So let's go ahead and write this down. This is the spread, is equal to 1976.487 if you round to 3 places. Okay, so now let's go ahead and find the mean for these two, because I need those two. Woohoo! So if I highlight the data, it autofills in the ALEKS calculator. Is that just too spiffy for words? Then you hit the X bar key and it gives you the mean. Alright, so that's going to be X1 bar is equal to 44,878.85, and then let's do the same for the second one. If you just double click it, it'll also fill too. So x2 bar is equal to, when I hit the mean key, gives me 43,099.25. So I'm writing those all down on my paper. So I've got the spread, I've got this mean for the first for the first sample, and mean for the second. So now we can go ahead and do the computation. So it's going to be, oh, I should have stored. That's okay. It's all good. So I'm going to put in 44,878.85 minus the second one, which is 43,099.25, divided by, and notice how I highlighted the whole difference, divided by recall. Remember, recall was that spread that I had. Okay, and so we now can find out. Now we also have to subtract the parameter. So let's watch the trick with the parameter. When you subtract the parameter, because remember it was x1 bar minus x2 bar, that was the estimating statistics, and the spread is mu1 minus mu2. Well, if you're assuming that it's equal, remember, assuming innocent until proven guilty. If you're assuming that it's equal, what happens when you subtract two equal things? For example, 5 minus 5. Yes, you're right, you get 0. So it turns out mu1 minus mu2 will always be equal to 0 for a hypothesis test where we're assuming that mu1 is equal to mu2. And if you go back to the null hypothesis, you can see that. Let's go back up again so we can see where we've got that written in here. So we have the null hypothesis will always have that equality. So you have mu1 minus mu2 equal to 0. Now you could have a case, we don't in ALEKS, but you could have a case where I believe that the mean of the first one is less than the mean of the second one by a difference of 2. In other words, I think it's always going to be 2 away. Then instead of having a 0 here, you're going to have a 2. Okay, all right. So then we now have the test statistic, and that gives us 0.9003, and we want to do that to 9 places, so we'll just put 900. And then our critical value is we want to find out if it's greater than mu1. So what I'd like to do now is just imagine, if you will, maybe I can use Paint. Let me do that. I'm going to open up Paint program. I think that will be valuable. So let me do that. All right, you can see I have Paint open and I've drawn a bell-shaped curve. This point here, if this is the Z distribution here, would represent, I'll use this line here, that we're the middle. That guy there would represent Z equal to 0. All right, and then we've got a test statistic of 0.99, so we say, well, right about here. So I'm going to draw a little arrow here. This is what the test guy came out with. From the sample, this is what we got. Z equal to 0.900. So it is far away from the mean, but how far is far? Well, if we're testing at a certain significance level, we can figure out how far is far. So let's go ahead and take a look at what the significance level is by looking back in Alex. .05. So that means when I go back to my Paint program, I want to find out what's the Z-score that corresponds when the area to the right here is 0.05. And you said, well, Donna, how did you know it was area to the right? Well, let's look at our alternative hypothesis. Our alternative hypothesis, when we go back into Alex, says mu1 greater than mu2. That means that when you subtract mu1 minus mu2, that means it's going to be greater than 0. And if it's greater than 0, that's going to be to the right. So again, we're looking at our Paint here, and so I want to find what is the Z-score that corresponds to here. And so we can use the Alex calculator to do that. So I'm going to hit Z of 0.05, and it gives me 1.645. And how many places do they want me to do this? To 3 decimal places. So 1.645. All right. So when I go back to my Paint program, this here is 1.645. So I can see that this test statistic, it's not exactly 0, but it's not way far away either. There's a 5% chance that'll get a sample that has test statistic greater than 1.645, and this is indeed true, that the mean is of the first one is equal to the mean of the second, or correspondingly saying that the Z-score is 0. So that's going to be our critical value, our cutoff value, 1.645. If this were a two-tailed test, instead of doing 0.05, you would do half, 0.025 in this tail and 0.025 in that tail. And you would have a positive value that Alex will give you, and then you'd put a minus sign in front of the other value. Because of symmetry, it'll give you, because of symmetry, the numbers will be the same value and absolute value, but you just have they'll be opposites of one another. So again, I've now opened up Word so that we can capture what's going on. We see that the test statistic I think I've got too many statistic is stuttering, sorry. The test statistic is not in the critical region. You said, what do you mean the critical region? That's this region here. It's not in this area right in here, so it's not in here. So since it's not in this critical region, boy, I wish I could draw this prettier. Anything over here that falls in here, I'm going to reject H naught. I'm going to say, you know what, I don't think the means are equal. So if I fall in this area, I'm going to reject H naught. Isn't my handwriting beautiful? Woohoo! Okay, so I'm going to reject H naught. Well, that's not the case. Our test statistic is not in the critical region. So since it's not in the critical region, guess what's going to happen? Then I'm going to say do not reject H naught. Hey, don't act up on me. Do not reject H naught. Not in favor of H1. Isn't that just beautiful? All those knots just line right up. So if the test statistic is in the critical region, then you do reject H naught, and therefore you're in favor of H1. But in our case, not in the critical region, do not reject H naught, not in favor of H1. So do not reject H naught. I do believe if we look back at the problem in English, we'll see which way we should answer the question. So it says here, can we reject the claim? Our decision was do not reject H naught. Since the claim is H naught, well, you said, Donna, how do you know the claim is H naught? Less than or equal is the claim. And that is H naught, less than or equal. So since H naught is less than or equal, and our decision was do not reject it, then our answer is no, we cannot reject the claim. If it were in the critical region, then we would reject the claim, and therefore it would be yes, we reject the claim. Okay? So you have to be real careful, because sometimes the claim is the null hypothesis, sometimes the claim is the alternative. So the thing you do first is make a decision. Either I'm rejecting H naught or failing to reject H naught. In other words, we say that a person, there's not enough evidence to convict. We don't say they're innocent. We say there's not enough evidence to convict. Do not reject H naught. Or we say that there is enough evidence to convict. Okay. All right. So let's go ahead and click this button and get our little happy good sign. Yay! We love it when it says you got it right. Woohoo! So I hope that helps. If not, feel free to give me a call at 813-9027. Bye-bye.